Lovely. Well, I can see a big full computer screen in front of me, lots and lots of smiley faces. If you are able to, please do put your cameras on, as I know that we all crave some sort of human connection, and it's nice to see a few familiar faces at this time. So if you're able to hear me, can you just give me a quick wave? And I get that warm, fuzzy feeling that this isn't all just some big hoax where I have to talk at my computer, and it is actually other human beings. So that's great. Really good to see so many of you here today. Thanks, Cliff. Always a smile from you. It's really great to see so many of you here. So hopefully that's an indication of that we've got a topic that you're all interested in. For today's session, as normal, we're going to record it so that you can watch it back again later, or any of your colleagues, and it'll be made available. As I said, if you can keep your cameras on, if your bandwidth permits, that is great, please. It just helps us interact. But as normal on these things, if you can keep yourself muted unless you're speaking, and we just avoid all that background noise. What we're going to use today is the chat box. So if I'm clever enough to try and find mine, if everyone can please navigate to the chat box now, and just for a bit of interest, instead of typing hello, if you can just type where you are in the country or the world, and that'll just get us to see if everyone can get their chat box working. Here we go. I'll type in mine. There we go. So we've got a bit of a spread. Okay. Yeah, I can see we've got people pretty much all over the country there. Have we got, can't see anyone from Scotland at the moment.
Yeah, there we go.
Is there Scotland in there? Somewhere from Scotland?
Near Edinburgh, Miles Stedman.
Brilliant.
Hello, Miles.
Oh, yeah, great. So it looks like we've got a pretty good geographic spread this morning. Now we're going to be using the chat box because we've got nearly 60 people on the call. We're obviously not all going to be able to talk, but what we can do is we can all put stuff in the chat box at the same time. So that's going to be a really powerful way of us communicating and sharing information. Because there's clearly an awful lot of experience here, and I'm sure you don't only want to hear from me and Cliff. We're also going to use breakout rooms today. That should all happen automatically. So you will magically go into a breakout group and then magically come back out of it. The only issue with these is if you're on a mobile phone. If you're on a mobile, it doesn't work, I'm afraid. So if you're on a mobile and have the option of going to a laptop, please do that. If not, you'll just miss out on that little bit. So please stay on and you'll still get lots out of the session. As always, if there are any IT issues, what we suggest is that you just log off and then log back in using the same link that you did just now, and we'll just let you back in and there should be no issues with that. Okay, well, I think that's it in terms of the technical administration. So what I'll do is I'll hand over to GIRI Executive Director, to Cliff Smith, who will give a bit of, so thanks, Helena. Oh, I've got a question popped up on my screen. I think that's not for me. There we go. So I'll hand over to Cliff, and Cliff, if you want to kick us off.
Right. So we should be sharing the screen now. Well, good afternoon, and thank you for joining us in this second GIRI Forum of 2021, following the successful forums of 2020. My name's Cliff Smith, and I'm a chartered engineer, civil engineer, with 40 years experience in the construction industry. I was recently appointed Executive Director of GIRI following the sad loss of our founder, Tom Barton. There has been considerable discussion and many views expressed over the years throughout the construction industry about the need to get things right and the processes to do so. Quite apart from any legislation that might arise in the future, it must be a no-brainer that we want to get things right. GIRI are trying to help the industry eliminate error and show that the drive to improve quality of our product and our outcomes can inform and improve all elements of project delivery. A key factor in achieving improvement is learning from past mistakes, and today Nick is looking at lessons to be learned from the Edinburgh School wall collapse and Florida bridge disaster. In 2015, GIRI carried out a research project looking into the costs and root causes of error, leading to the publication of our report Strategy for Change, which you can find on our website. This chart illustrates one of the most important findings. The total cost of construction, or shall we say GDP, is currently in the region of £100 billion. Our research showed that 21% of this cost results from dealing with errors. Now, this is a research figure and may be a little higher or a little lower, but it is in the right order of magnitude. And we can see these 4 areas of error: the direct cost of error, which is basically the resources needed to put things right; the indirect cost of error, where you're affecting third parties and you've got follow-on work to do; unrecorded process waste, which is where errors occur but they don't get recorded, they just get dealt with; and latent defects, which is errors which occur after a sort of defects liability period have passed, and those are all well known to us. An average construction company makes, let's say, 2 to 4%, something like that, if they're lucky. But if it is spending circa 20% putting things right, then it becomes perfectly obvious the right way to proceed is to work towards zero error. And this is where we come in. Our research looked into the root causes for error and found these ones to be the top 10. You might find some of them surprising. Planning, design, communication and culture are high on the list and feature above commercial pressure and skills. Our activities following the result of the research have been targeted on these high-ranking activities. When we talk about it as the cost of error, let us remember, though, it's not just about the money. There are other wider consequences when we get things wrong. Avoiding error can improve our carbon footprint through avoiding waste and also saves lives. Some Australian research has shown that approximately 37% of accidents occur during the rework process. A few of the other implications are highlighted here. Undermining of corporate messages about taking pride in our work and the associated reputational damage. And we all know about the human tragedy. Have any of you listened to the enquiry podcasts or live recordings about the Grenfell disaster? The evidence suggests the behaviour of those involved was not very different from many of their peers. We in the industry are collectively responsible for what happened, and there are going to be consequences for us all when Dame Judith Hackett's recommendations are implemented. She has been incredibly scathing about the whole performance of the construction industry, and the forthcoming Building Safety Bill is the result. The underlying GIRI message is a force for improvement, and we will help the industry respond to the requirements of the bill. In this respect, our forum today is particularly pertinent. So, what are our aims and objectives? Originally, we secured funding to research the industry. The report showed how much could be gained by a structured approach to improving error reduction. So we set up GIRI Limited with these 5 key aims: create a culture, change attitudes and harness leadership, engage all stakeholders in the industry, share knowledge so that we are all aware of what's going on in terms of both processes and systems and technology, and improve skills across the sector and get a positive approach. GIRI Limited was created as a not-for-profit company paid for by subscription. Initially, we had 14 companies, and this has now moved on considerably. So what are our priority themes? We want to deliver a strategic campaign. We want to develop some skills through a skills program. We want to improve processes, systems and technology, and provide opportunities for people in the industry to share their knowledge and experience. We now have 58 members, I think it is, and this is an indication of the spread of that membership. What you can see is we've got clients, consultants, contractors, we've got the lawyers, we've got the insurance industry represented, as well as members of our supply chains. So I'll just move on towards today's talk and leave you with this thought. Any part of this sector who thinks they can survive by standing still or defending their current territory is sadly mistaken. I'll now hand you back over to Nick, who is going to help us to learn some lessons.
Brilliant. Thanks very much, Cliff. That's great. Okay, so what we're going to do today is have a look in a bit more detail at two recent, very significant errors, structural failures. So I'll share my screen if I'm clever enough. Here we go. Let's share this. So we're going to look at the Edinburgh School wall collapse and the Florida bridge collapse. So I'm going to zoom out. This is basically just a big whiteboard that we're going to use for exploring these topics today. So the first thing we're going to do is have a look at the Edinburgh School wall collapse, have a dive into that, and we'll have a think about why did we think that happened. We'll then have a look at the Florida bridge collapse and then ask the same question, why did that happen? We're then going to take what we deduct from that and then ask ourselves, what should we do about it? We'll have a quick look at what GIRI teaches and what GIRI does now, and then reflect on what lessons can we take away from these two case studies. Now, throughout all of this, I'm very conscious that we've got 60 odd people in the room who've got a vast amount of experience. So I'm not going to be telling you the answers. I'm going to be trying to provide some background information, and then in breakout groups and through discussion, I'm hoping that you can basically learn from each other. So let's start off by diving into the Edinburgh School wall collapse. Now, this is a bit of a poison chalice, because I have absolutely no doubt that there are several people on the call who will have an intimate and expert knowledge of this, possibly involved with it personally. So what I'm going to do is I am going to try very hard to stick strictly to what has been stated in the SCOS report and the various other reports. However, we have got the chat box running. So if you know something from personal experience about this project, please don't hesitate to add it to the chat box so everyone can see, so that we can share in your knowledge. So I'm sure you're all very aware, at least in outline, of this this disaster. So in 2016, Oxgangs Primary School up in Scotland, during high winds one night, virtually all of this masonry wall fell down, collapsed into the playground. This area alongside the wall is where the children line up to go through that door. So had this happened during the school day, this could have been a seriously bad disaster. It is only luck that meant nobody was killed, because it happened at night. So let's have a look at what actually happened. So this is a completely standard type of construction. It's blockwork and brickwork wall, blockwork on the inside leaf and brickwork on the outside leaf, tied together with brick ties every third course of bricks, so every one layer of blockwork. And in between the bricks and the block, you've got the insulation panels. I'm sure you all are thoroughly familiar with this. And we can see it here. We can see the blockwork on the inside, insulation panels. These red dots are where we've got these, what's left of the wall ties. And then we can see the brickwork on the outer face. Now, a number of things went wrong to lead to this collapse. But essentially, it came down to the fact that these brick ties were not holding the outer leaf in place. And there are a number of elements to this. One of the elements was that a decision was made to build the inner leaf, the blockwork, excuse me, first, so that they could get on with fitting the inside of the building. Obviously, they wanted to make the building watertight. Now, what that meant was that the courses didn't go up at the same time. So several of the courses weren't aligned properly, so the brick ties couldn't all be connected in. You can also make out from this picture here, if I zoom in a bit more, that there's diagonal bracing inside the steel frame. So wherever that diagonal bracing clashed with the brick ties, it meant there weren't any brick ties there. In some places, I believe the insulation was wider or thicker than planned, so it didn't have the right embedment on the brick ties. So there were a whole host of different reasons why we ended up not having the brick ties embedded enough. And let's have a look at some of the words from the report. So the primary cause of the collapse of the wall at Oxgang School was poor quality construction in the building of the wall, which failed to achieve the required minimum embedment of 50 millimetres for the wall ties, particularly in the outer leaf of the cavity wall. The poor quality relates to all three of the following aspects. 1, the direct laying of the bricks and the positioning of the wall ties. 2, the direct supervision of the laying of the bricks and the positioning of the wall ties. And 3, the quality assurance process used by the subcontractor and main contractor to confirm the quality of the construction of the walls. Okay, so the consequence of this has been that all schools conducted, I think it's over a 20-year period, but over a long period under the same contract had to be investigated. Last I heard, the cost of all those investigations was running at somewhere around £350 million. So that the direct cost of trying to rectify these errors. 17 schools were closed for a prolonged period after this collapse, and clearly it raised concerns over lots and lots of other structures built over the same period. Now, what I want to do is just zoom in and consider something that we look at in our interface courses, and that's what we call the interfaces triangle. So when we have an interface, we can think of a physical interface. So in this case, it might be how the bricks tie in with the brick ties, or you might think how a pipe clashes with a beam. A physical interface, we call that space, spatial, the space element of interface. But you've also always got the people element, you know, who is interfacing with who, what organization interfaces with what organization. And you've also got the time elements of interface. What has to happen in what order? What decisions have to be made before other decisions? So let's reflect on that for this wall collapse. So let's look at space. Well, we've already seen that there's a space element. The blockwork didn't align, and these weren't embedded enough, you know, fairly fundamental. Let's have a look at the time element. Well, actually, we've already heard that the sequencing, the order that work was conducted, had an impact. And what about people? Well, this is a quote from the report saying, a fundamental aspect, as illustrated by the many previous failures, is for the design team to know that what they thought was being built was actually built. Okay, so it wasn't that this was designed wrong, but because of the different groups of people, it wasn't clear who was doing what. So let's have a look at some of the consequences of this, or some of the other considerations from the report. So it said the only time that the defects could have and should have been found was when the schools were being constructed through a process of proper supervision and inspection, and the procedures for buildings need to consider whether the drive for faster, lower cost construction may be being achieved to the detriment of quality and safety. And something that's quite pertinent at the moment is that the report also found that a significant number of breaches of fire stopping were revealed across all of the 17 projects, so the schools that were shut, and quality management systems as implemented on the projects were insufficient to prevent the defective construction. Now, the final thing I'll just bring up when we're thinking about this, this collapse, this is a standard detail. This is taken from the International Masonry Institute, so it's not from this job, but it is a standard detail for the type of construction we were looking at. So block work, brickwork with insulation in between. And the thing I'd highlight is just how complex this is. This is a very normal bit of construction, but just look at the complexity there in that detail. And a quote from the report said there was widespread failure to incorporate designed elements that were shown on engineers' drawings. It's appropriate that the construction industry reviews how effectively information is produced, coordinated, presented, and communicated to contractors and to tradesmen on site. And interestingly, that ties in exactly with one of the root causes of error, the top root causes of error, which is poor communication of design information. So what I'm going to do now is we'll zoom out and we're going to look at this question. So why did this happen? So I'm going to stop sharing and going to ask Helena, could you please put people into breakout groups? We'll go into breakout groups for 5 minutes. And what I'd like you to do, please, in your breakout groups is just discuss why did this happen? Try and answer that question. Why did this happen? And we'll come back in 5 minutes and have a bit of a brain dump and see what you've collectively come up with. Okay, so hopefully you were able to have a bit of a discussion there and maybe some different ideas came up. Can I please ask you all to open up the chat box, and if all of you please can just type in the one thing you think was most relevant that you took away from that conversation, just one reason why you think that happened. So everyone just type it in. Okay, we've got something about culture from Jan, brilliant. I've got a couple of culture, greed. So behaviours, really interesting. So a lot of these, not my responsibility, behaviour, culture, programme pressures. So there seem to be an awful lot here that are coming down to the way people are behaving or the way they're working with each other. We've had a couple of mentions of sort of systems and checking processes, something about specifications, but there's definitely a big lump of culture and the way we work together emerging here. Brilliant, really interesting. It's quite nice if you can follow as well, see what everyone else is putting in the chat box there. So what we're going to do now is we're going to look at that list that GIRI found from the research. So they identified the top 10 common root causes for errors. And we're going to do a quick vote. So you're all going to get 3 votes. And what I'd like you to do, please, is pick from the list of 10 the 3 things that you think were most relevant on this project. It's not exact, but we just want to get a feel for it. So if you could share that poll, please, Helena, and then each of you just select the 3 things.
Just bear with me, I need to get the presenter.
Oh, you need to get the ball.
Presenter privileges back. So.
Yeah, can you do that? Yeah.
You might have to give them to me, I'm not sure.
See.
Oh, maybe I've got them.
There you
Let's have a look.
There you go.
That's it.
There you go.
Yeah, hang on a sec.
The poll is coming. There's clever things going on in the background here. Okay.
No, just bear with me, please. Open poll. There we go.
Oh, there we go. Okay, so the poll should have popped up on your screen. So
we have a minute.
Yeah, please just pick the 3 that you think are most relevant to the Edinburgh Schools wall collapse. Seems a long time in silence, doesn't it? A minute. You think, oh, a minute, that's not long. So you can just click on those little check boxes next to the list. You just click on them and you vote by clicking in those boxes, and you should have up to 3 votes. There we go, great. So I think we should be able to see the results now through some computer magic. Those results there, Helena. You can see the see the anticipation in everyone's faces here. It's like waiting for the lottery results. Oh, there we go. Okay, really interesting. Let's. I'm just going to screen grab that as well, so we've got a record. Okay, so it's interesting there. What have we got? So poor culture coming out highest with 67%. Poor supervision 48%. And interestingly, what's really low, we've got hardly any for late design changes, very few for incorrect and poorly coordinated design. Interesting. Okay, great. Well, that takes us through our first case study, which is the Edinburgh Walls. Am I able to share again, please, Helena?
Yeah, you should be able to, yeah.
Great. And what we'll do now is we will have a look at the Florida bridge collapse. Now, instead of me talking, what we're going to do is watch a video, which has been produced by the National Transport Safety Board, US organization. I'm going to play it on my screen, so you should just sit there and it'll happen and you can watch it. But also, I've just put in the chat box a link to the YouTube video. So please just watch the video, but if it doesn't work, you can click on the link instead. So here we go. I will try and play the video, and here we go.
On Thursday, March 15, 2018, the Florida International University pedestrian bridge collapsed, killing 6 people and injuring 10 more. The collapse occurred 11 miles west of downtown Miami in Miami-Dade County, Florida. The Florida International University pedestrian bridge was located on the west side of the intersection of Southwest 8th Street and 109th Avenue. The elevated pedestrian bridge would have connected the university with the city of Sweetwater by extending over Southwest 8th Street and the parallel running Tamiami Canal. The first section of the bridge constructed was the span across 8th Street, and that was the section that collapsed. The bridge section was built on the ground in a construction yard adjacent to the roadway, and then moved onto support piers using 2 self-propelled modular transporters. Building the bridge alongside the road before moving it into place is a construction process called accelerated bridge construction, which reduces on-site construction time and minimizes traffic impact. The overall conceptual design had the appearance of a cable-stayed bridge. However, the central pylon and steel pipe stays were not load-carrying structural elements. Instead, the functional design was a truss structure that was unusual for being constructed out of reinforced concrete and also for having the truss members aligned in a single plane. The bridge section that spanned Southwest 8th Street was 174 feet long and weighed 950 tons. It contained a deck, vertical and diagonal truss members, and a canopy. The truss members were numbered 1 through 12 starting from the south end of the bridge. The design of the bridge was non-redundant, meaning that failure of an individual truss member would cause collapse of the bridge. The concrete for the section was poured in 3 stages. First the deck, then the vertical and diagonal truss members, and finally the canopy. Separate pours formed discontinuities in concrete structures called cold joints. In this bridge, cold joints were located between the deck and the truss members, and between the truss members and the canopy. Within the concrete, reinforcement was provided by steel bars and larger diameter steel post-tensioning rods. These rods were pulled in tension and locked into place after the concrete had cured in order to ensure that the concrete was loaded in compression. The post-tensioning rods and steel reinforcing bars were to carry the tension loads of the completed bridge. Before the bridge was moved onto the piers, truss members 2 and 11 were post-tensioned in the construction yard, counteract the tensile forces developed while the ends of the bridge hung over the transporters when the span was moved. After the bridge was placed onto the piers, truss members 2 and 11 were under compression, and the post-tensioning rods were detensioned. Before the bridge section was moved into position on the piers, cracks were observed in the concrete at and adjacent to the full joint between the deck and members 11 and 12. The cracking got worse once the bridge section was placed on the piers. These cracks continued to grow over the next 5 days, and numerous photographs documented the progressive cracking in the structure. In response to the cracking, a decision was made on the day of the collapse to retension the steel rods in truss member 11. Workers were retensioning member 11 when the collapse occurred. The road was not closed while this work was taking place. The bridge section was placed onto the piers on the morning of Saturday, March 10, 2018. It collapsed 5 days later on the afternoon of Thursday, March 15, 2018. The collapse began at the north end of the bridge, initiating at the pull joint between the deck and truss members 11 and 12. Large shear forces and insufficient reinforcement across the pull joint at this location led to the steadily growing cracks and structural failure. One bridge worker was killed in the collapse, as were 5 people in vehicles under the bridge. 5 bridge workers, 5 other people were injured.
Okay, I find that quite fascinating, that video. I don't know if any of you have seen it before, but some pretty stark lessons there. So what we're going to do is put you back into breakout groups again, so that you can answer the same question, please. Why did that happen? And so, Helena, if I can ask you, please, to put people back into the rooms, and we will reconvene in 5 minutes to see what you think. All right. See you. Thanks. See you later. Cheers. Hello. Welcome back. There you go. I can see people popping up all over the place. Brilliant. Okay. So I'm really interested now to see what you all came up with. So what we'll do is the same approach again, where if you can all please open the chat box and type in just one, but just type in one root cause. What do you think was the root cause of this disaster? So we've got a comment there, controlling mind. Rupert, do you want to just expand on that concept, controlling mind?
Yeah, well, we were talking about who designed it, and was that designed for permanent condition, and there was clearly some temporary to permanent to interim way the loads were distributed, and then as the cracks started to occur, who was stopping them from shutting the road or making some decisions about it and deciding to retension some post-tension stuff? There was clearly some decisions that were made and clearly some that weren't, and in all of that, who was making those decisions? And I don't know, but you can imagine it was a fairly complicated, emotional, lots of people in meetings shouting at each other, and who made the mind up, you know.
It's interesting, that, isn't it? Because you can see the photos, but you can see that there's some sort of group think going on here. You can imagine a whole bunch of people looking at each other wondering whose responsibility is this. Yeah, really interesting. We've got a comment about it's all about standards, substandard people proposing bog standard solutions in a non-standard way. That's a good one, Douglas. What else? Inadequate management of permanent and temporary work. So again, that issue of temporary and permanent situations. Inadequate link between construction and engineering. Okay, so there's a lot of really interesting stuff there. So what we'll do now is we will, please read through those comments, really interesting ones. I'll capture them and stick them on the whiteboard. But Helena, could we run that same poll again and ask everyone again to pick what do you think were the top 3 from the GIRI identified root causes of error for this Florida bridge collapse? Just vote for what you think were the top 3 root causes at play. Just got a few more seconds before we'll start to see the results. Okay, right, it's be interesting to see how this compares. Those results will be coming any second now. There we go. Thanks, Helena. So interestingly, we've got top 1, incorrect and poorly coordinated design. And that was very different to the previous example. Lack of attention to construction during design. Helena, can you just make it so that I can share my screen and then I can put up the comparison between these two examples? There we go. I think I can share now. So let's just crop this down. Okay, so if I share my screen, we can see these two things side by side, the results of these 2 different disasters. So interestingly, we've got this one, E, incorrect and poorly coordinated design, really significant, the top root cause for the Florida Bridge, but not so relevant for the Edinburgh Wall collapse. Anyone see any that are, so poor communication of design, pretty similar, sort of medium for both? But I find this interesting because we can see that pretty much all of those root causes are relevant in one or other of the, apart from late design changes. Neither of these disasters incorporated a late design change. So yeah, quite interesting that that is commonly the cause, but for both of these, a late design change wasn't relevant. Okay, so what I'm going to do now is sort of ask that question. So what should we do about this? The whole point of looking at these disasters is to learn something from it. So what I'm first going to touch on is what does GIRI focus on now? So we can think of it as being an effort, a drive for an error-free culture, and there are a number of elements to that. We think about behaviours, and that was mentioned a lot of times when we were considering the wall collapse. We can think about communication, how we communicate within construction teams, and also the processes we use. So let's have a look at behaviours and what we focus on with GIRI. One of the key concepts that we drive through all of the training, particularly at a low level, particularly with our site supervisors and managers, is this concept of build it in your brain. Before you construct anything, you should know what it's going to look like. You should know what correct is before you do it. And out of this comes the next key concept, which is press pause to avoid error. If it's not going to be right, then press pause. So we can see that those concepts probably would have been particularly useful to avoid both of these problems. The other part of behaviour that we really focus on is this idea of helpful disagreement, where people are being helpful. They're all trying to achieve the same thing, but you're not afraid to think for yourself and you're not afraid to challenge. And actually, the really dangerous area is up here, this unhelpful agreement. People doing exactly what their job says, exactly what they're told, even if they know that it might be wrong. So it's this unhelpful agreement, doing exactly what you're told, that we must avoid and get people down into this helpful disagreement, thinking for themselves. In terms of communication, we focus on closed loop communication. So it's not just encoding a message and sending a message, pushing information out. We understand that communication relies on getting feedback. So the message you send being decoded, and then the person who's decoded it encoding a response, encode their message, transmit it. And it's only when you receive their response that you can actually be confident that your message has been understood. And the superpower that we always talk about is open questions. If you can ask people open questions, you know, why are you doing that? What are you doing? Where is this happening? When is this happening? Then you can actually find out what's going on. So these open questions are the key to effective communication. And then when we consider process, we've already had a look at this space-time people concept for identifying the complexity in interfaces. And for our leadership, we talk about doing a pre-mortem approach where we look at concerns, then identify the cause for those concerns, and then countermeasures to those causes. So we've got some structures. Now, this is just obviously dipping our toe into some of the things we already do within GIRI, just to give you a 10-second taste. But I think the final question we really need to ask is, what lessons can we take away? So I'm going to stop sharing my screen and give you all just a couple of minutes, so 2 minutes now. Can you think of any key takeaways from either both or from one of those case studies that we should learn from what we've seen? What is a key takeaway that you think the industry should pick up on? And if you can type those into the chat box, and then we'll see what people have come up with. So it's interesting, Paul, you've identified there that Edinburgh was completely standard, Florida was not standard at all. Do you want to comment on that? The sort of so what from that observation?
That was in relation to your comparison of the two polls that took place. So the root causes of the errors were different in each case. In Edinburgh, the work was bog standard and went wrong. In Florida, the design was extremely unusual, and it would, when you think about it, how the construction personnel could have understood the complexity of the design and what was important and so on. Extremely difficult for ordinary site people to understand. So it's hardly surprising that something did go wrong.
Yeah, interesting. Okay, thank you. Thanks. And then that sort of leads into, there's a comment here from, it says, Severton, I don't know if that's a surname, sorry. When something moves from standard to non-standard, stop and review with the right people, not just who's available, and too close to the problem. So that's an interesting thing, isn't it? The idea of being too close to the problem.
Yeah, I think it's Steve. Yeah, Paul's previous comment was what prompted that to me, is that even Edinburgh, it was standard until someone said, actually, we'd like to do this differently, you know, or we've got that bracing in the way, etc. Suddenly it looked standard still to anyone who was putting that up, but actually it was different. And those kind of situations, you have to just pause and test.
Really interesting. Okay, so it's just a subtle, seemingly subtle change, but can have massive implications. And that sounds like it ties back to that idea of the interfaces triangle. You know, there's one little difference in terms of, oh, we've just changed the sequence, but actually that has a massive implication to the way the thing fits together. So yeah, great. Thanks. Yeah, sorry, I can see you've got your Chris. Yeah, go for it. Oh, you're on mute, Chris. You'll have to.
How's that?
Brilliant.
Right, on the Edinburgh one, they decided to build the inner leaf first, but they probably didn't give consideration to the fact that the wall as a whole with 2 leaves is necessary to prevent the wind loading damage. If they had built the inner leaf first, before the second leaf, the brick one, and the gale had occurred then, it could have killed the construction workers. So it's very much a health and safety thing, because that 100 mil block wall would have very little strength against the wind forces.
Interesting. And also interesting because we seem to be going back to that idea of temporary versus finished state of the structure as well. That seems to be coming into both of these. Brilliant. Thank you. Let's have a look, see what else we've got in these chat boxes. We've got one from Miles here. Both the designer and constructors need to understand each other's culture and concerns better. Miles, do you want to expand on that at all?
Yeah, thanks. Well, my experience is that as a designer, you tend to work from the office and say, you know, why do things go wrong on site? And out on site, you have the opposite culture. It just occurred to me as we were talking through both these examples that if we just took a bit of effort to educate ourselves about the issues that the other side faces, as it were, it would help us understand and plan ahead to avoid these problems.
Interesting. Yeah, really interesting. So seeing it from the other perspective, and that sounds very like this communication loop. And that, in fact, Martin Bond, you've put something similar to that in terms of a cycle of communication. Do you want to expand on that?
Sorry, I just unmute there. Yeah, just I think one of the things is what I didn't understand on the first one was when it said, you know, the designer thinking what, you know, just believing what they thought was being built had been built. But I kind of understood it more in the second one, is that until you get that feedback loop where maybe you review a method statement or a proposed construction sequence, you don't actually know if what your intentions were, you know, which may or may not have been on the drawings, are actually coming out in reality. And without the feedback loop between the contractor and the designer again, is that you're not going to be able to pick up anything where you go, oh no, don't do it in that order, or oh, it doesn't work if you do that bit first. And you know, it's only when you can actually close that loop out that you actually have communicated things properly.
I think that's a really powerful observation, isn't it? And actually, it's quite a hard challenge for us to confidently say no, nothing is wrong, but we can quite easily say, is there a feedback loop? Has the designer seen what's being built? You know, that might be something that is achievable and is almost our safety net to make sure that we're avoiding these types of problem. Maybe in both instances that's relevant. Okay, well, there's loads and loads of really good stuff in the chat box here, but I'm conscious that we are already 2 minutes over what we are supposed to be doing. So I'm going to wrap up there, say thank you ever so much for all of your contributions. I found that fascinating. And please do look through the chat box. And I'll hand over now to Cliff to close us out, please.
Thanks, Nick. That's been really interesting. I think just reflecting on the comments in the chat box, for me, overwhelmingly, the question of culture comes to the fore, and this sort of behaviour within the construction industry. A a gentleman who's just written at the end there, Dennis, I think as a very pertinent comment. The culture and behaviours of people in the construction industry is where we really need to concentrate our efforts. That's what GIRI is one of the top reasons for GIRI pushing forward so much to improve the industry. Designers and contractors and clients and the interfaces between them, it just leaves us with a lot of work to do. And we've had a number of reports going back to Egan and the fellow before that, who doesn't spring to mind immediately, but they're all coming up with this same thing about collaborating and culture, and we still don't seem to have got it. And what GIRI is trying to do is to push forward on that agenda. So thank you very much for joining us today. I hope you found it interesting, and I hope you're taking away from the forum something you can go and discuss with colleagues and hopefully help us to improve as an industry for everybody's benefit. Thank you very much.